Hello, everyone. I hope you can see my screen. And I hope that you can also hear me well. So I'm joining from Netherlands. And this is my first slide, and it will be the last slide again. So I would like to challenge Dan once again about what is robotics is about. Is it programming the work or programming the motion? I'm not looking for an answer today, but I just want to give my interpretation. So if I can move to the next slide. Yes, I would like to a little bit mention about myself, because I believe that this is an important part of the lab culture as well. So we are talking about the diversity and the diversity both in culture and I guess perspective. So I born in Ankara, capital city of the Turkey, and I spent all my life there. I was the first generation college educated family member, and I met with Uluç at Bilkent University, and he encouraged me actually to continue with a PhD. So I guess this is the inclusive part of our culture. And then I moved to Philadelphia. There I spent quite a bit time, like 6-7 years as a PhD student and a year postdoc with them. And during that time, I also had a chance to meet my wife, Alyona. She is from Russia, Vologda. And then we say that we want to learn more about the other diverse, the other cultural values in the world. And Europe was the other part I would like to explore. So we would move to Germany first. There I had my first daughter, Amelia. Then we moved to Eindhoven. And I had my second daughter, Olivia. She's 5 months now, and I love spending time with them. And people are really very important in my life, and I believe that continuing as an academic person in at the university allows me also influence other people's lives. So this is the privilege, in addition to doing maybe cutting edge research. So a little bit about the Kod Lab culture from my perspective. So when I think about the Kod Lab research, it's curiosity driven. So it has some intellectual value. So we are not really just looking for an application and trying to solve the world, some problem, but also try to give some hints, what might be the next step. And usually it's a multidisciplinary approach. You already see many examples that bring different engineering principles, science, and other fields together. And I guess Dan's perspective and interest in different science, math, engineering influence a lot. Again, it should be fundamental. So we give priority for quality over the quantity. So I think that comes from our responsibility for the robotics community. So I think Dan's high research integrity and standards has this influence on all of us. So now I do my research. I always look for the quality, not necessarily trying to finish a number of work every year. And again, multidisciplinary. I believe that diversity of the people were very important in the lab. Openness to different perspectives. And going back to this curiosity-driven approach, I believe that one thing I like in Kod Lab was I was always encouraged to fail and not to be scared. So offering a safe environment to innovate, I believe this is something Dan managed a lot very well. And I would like to also achieve such things. But going back to some of the research experience we had, so my first work was more on the coordinated robot navigation. It brings some tools from machine learning, robot motion planning, and the topology. And it was a little bit difficult at first to talk to robotics community. Ideas were new. We were pushing the limits. From a scientific perspective, I was very excited about this work because this was the first time these ideas of sequential composition of local behaviors were done based on some explicit symbolic relation. So we were able to use the mathematical relation between the hierarchies, but it was really difficult to talk to robotics community about that. Then I realized that one thing is I need to pay attention to my audience, roboticians, And I see that the same ideas can be applied in a lower dimensions. The idea is apply machine learning to understand the structure around the robot. And we came up very simple ideas, like you can use the sensory information, construct some convex region, and say that if you want to reach a destination, just move to the closest point. And from my perspective, this is a continuous application of the sequential composition. You have millions of the maybe local controllers. They are just abstracted by your current position. And then this was, I believe, the first evidence that we were solving some navigation tasks or programming a robot, not really designing energy-based control. It was really, we were designing the motion right away, by using these new principles. And then I start questioning about my approach to research, and I pick simplicity as the baseline, because when I look at the other influential work from the Kod lab, I see that the ones they are really change the perspective. They are really simple in terms of the ideas, but very effective when you apply in practice. And currently, one topic I work is the motion prediction for motion planning. And from a programming work perspective, the current approach is using these energy-based invariant sets. These are good, but I find some limitations. The invariance is inherently designed for the stability analysis, not for robot motion planning. So for robot control, yes, that is the maybe way to go. But for robot motion, I find it too conservative, because an energy is not able to describe my motion. So recently, we look at some approach and yes.
Are you going to wrap up, sir?
Yeah, sure. Then finally, we come up with some new tools where you can apply and obtain the motion much more accurately instead of programming work. And we see the benefit in practice. You end up with faster motion, more agile and less conservative. And then that brings me to maybe my final question to Dan. Is it really about programming work or programming motion when it comes to robotics? So thank you very much.